All right, beta, let's start the class. And today we will be discussing about the PET scanning and PET scanning. पढ़ने से पहले we will be discussing one term which is called as radioactive tracer. What are the radioactive tracers and what actually they do and how they are going to be incorporated into the medical diagnosis, right? So tracer is actually any specific substance which is containing some radioactive nuclei in it, and it is being introduced in the body, like either it is being injected or it is being swallowed by a person in terms of a medicine or in form of a medicine or in a form of some sugar or glucose and so on and so forth. So a tracer is actually any substance or any element which is being consumed or swallowed by the human or by the body, and it is generally containing what? It is containing a radioactive nuclear. It is containing the radioactive isotopes or the nuclei, and when it is being introduced into the body, so it traces that part for which that specific organ or a tissue is is either malfunctioning or is causing some problem, or we have to diagnose that where the abnormality is in any of the body organ or body tissues. Are you understanding what the tracer mean is?
Yes.
So what are the different uses of tracers? uh, Normally they allow doctors to study the organ function, not just only the structure, but it also helps to investigate how any of the organ is functioning. Then it helps to show the blood flow, metabolic activity, and the performance of the tissues. Then it also helps to detect the abnormalities such as tumors, brain tumors का detect करना हो, या कहीं कैंसर का पता करना हो कि in any body part blockages का पता करना हो. That all is basically being done with the help of what? It all is being done with the help of tracers, right? So these are the specific use of the tracers, for what purpose they are actually being used. If you need to know the structure of an organ or any metabolic activity, blood flow, or about any abnormalities such as tumors, cancers, organ failure, and so on and so forth. So we actually use tracers. What are the different examples of the radioactive tracers? The radioactive tracers की different example है हमारे पास. एक element आता है या radioactive isotope आता है, टेक्नीटियम. ठीक है, इट इज बेसिकली यूज फॉर बोन स्कैनिंग या किडनीज की इमेजिंग के लिए ये यूज होता है. फिर आयोडीन एक हमारे पास ट्रेसर है जो कि थायराइड की इमेजिंग के लिए यूज होता है. फ्लोरीन हमारे पास एक ट्रेसर है जो कि पीटी स्कैन्स में यूज होता है to study the glucose metabolism. So you can name is just said for the example it is being written over here. Um, इससे कोई आपसे पूछने का नहीं कि व्हाट आर द डिफरेंट ट्रेसेस या नेम एनी ट्रेसेस, बट आपको सिर्फ ये जनरली पता होना चाहिए कि कौन कौन से ट्रेसेस जो हैं वो अवेलेबल हैं, which can be injected or which can be introduced inside the human body to study the behavior of the different organs or parts of the body. Are you understanding?
Yes.
Next is what are the different properties which are there for any good tracers. So for any of the good tracer, it should be having a short half-life. Can you tell me what is the meaning of short half-life? Any idea about it? It's just related to radioactivity we studied earlier. What is half-life?
It's the decay of a radioactive substance.
Yes, radioactive decay is happening continuously. So half-life is actually that time in which half of the initial number of count of the nucleus reduces to half. यानी कि इनिशियल जो भी काउंट रेट है आपके पास, अगर वो 1000 है और वो 1000 रिड्यूस होके कितना रह गया, 500 रह गए, तो कितना टाइम लगा for the given number of nuclei to reduce to half is actually known as half-life. So basically, any of the tracer is considered as a good tracer if it is having short half-life. Short half-life means that in a very shorter time it is decaying, it is finishing. Why? Because if it is going to remain inside a body for a very long time, it can cause a damage. It can cause a problem inside, right? So it should be having a short half-life. It minimizes the radiation exposure. Next, uh, it emits the penetrating gamma rays, not alpha or beta. इसका मतलब ये है कि गुड ट्रेसर वो होता है या अच्छा ट्रेसर वो होता है जो गैमा रेज प्रोड्यूस करे, ना के अल्फा और बीटा रेज प्रोड्यूस करे. So it should be producing the gamma rays, and it should be absorbed by the target tissues. ऐसा ना हो कि जिस टिश्यू को हमने स्टडी करना है उसको ये absorb ही ना कर पाए. So it should be absorbing selectively by the target tissue, and it should be definitely non-toxic because it is introduced in the body. If it is going to be toxic, so it is going to be problematic for one's body, right? So this is the basic introduction about the traces. So why we are just studying about the traces? Because in the PET scanning, the technology which we are just going to study, the very important part being used is the tracer inside the body. Yes, any questions so far?
No, sir.
Okay. Okay, जी, moving onwards, let's discuss about the technology which is a part of a syllabus and it's called as PET. So what P stands for? P stands for positron, E stands for emission, and T stands for tomography. So PET scanning means positron emission tomography. T is not generally for a technology, it is for tomography. So positron emission tomography scanning. So what is there in the positron emission tomography scanning? It is actually a powerful imaging technique which actually uses what? It uses the radioactive tracers which decay to produce the positron. Can you let me know what is the positron? Positron क्या होता है? Yes, Iman. We have studied this positron in our AS physics, particle
Um,
physics.
it's a antimatter of an electron that has a positive charge.
Exactly, exactly. Wonderful. So positron is what? Positron is it is the antiparticle, it is the antiparticle of electron. It is the antiparticle of electron. Pos positron is actually antiparticle of electron. So what it means? It means if electron is having a charge of E negative, then positron will be having a charge of E positive. Like it is equivalent, the magnitude of the charge is equivalent to the electron, but its sign is positive, right? So positron is a positively charged particle which is an antimatter or an antiparticle of an electron. तो हमें PET scanning के case में we are in a search of such tracer that when it is introduced inside a body, it should be decaying. That radioactive tracer should be decaying and should be producing what? It should be producing the positrons. It should be emitting positrons, right? So PET is using a radioactive tracers which decay by positron emission. Are you understanding? Okay, what is there in the PET technology? Very first, सबसे पहले काम क्या किया जाता है कि आपकी बॉडी के अंदर एक ट्रेसर इंट्रोड्यूस किया जाता है एंड दैट ट्रेसर की प्रॉपर्टी या क्वालिटी ये होनी चाहिए दैट इट शुड बी डिकेइंग इनटू अ पॉजिट्रॉन emission. Okay, how does the PET scanner look alike? This is the diagram being shown in the on the screen to you. Let's say if some PET scanning is to be done, so a person is going to lay inside a PET machine, and there is one rotating scanner inside which a person is going to be present. So there is one monitor on which the respective part of the organ of the body is being monitored, and there is, let's say, there's a bed sort of thing on which the person is laying. So person is being laid and it is being introduced inside one shell. This round scanner, this is actually a this circular part is actually a PET scanning part, a PET detecting part, right? So generally it is helping in diagnosing the brain tumors, cancers, body cancers, and like that. So PT scanning इस तरह होती है कि बॉडी में ट्रेसर डाल के इस तरह आपको अंदर इंट्रोड्यूस कर दिया जाता है मशीन के. नाउ लेट्स सी हाउ डज द पीईटी वर्क्स. ये सारा वर्किंग बिहेवियर, वर्किंग प्रिंसिपल और कैसा ये पूरा मैकेनिज्म काम करता है, यू शुड बी knowing about it. So let's disclose it one by one. So first of all, what happens in the PT tracers? In the case of a PT tracers, when PT tracers must decay, अभी हमने discuss किया कि PET tracer ऐसा होना चाहिए which should be emitting a positron while decaying. And positron is what? It is the antimatter or antiparticle of electron. तो कॉमन पीटी ट्रेसेस हम पहले डिस्कस भी कर चुके हैं. फ्लोरीन हो गया, ऑक्सीजन हो गया, नाइट्रोजन हो गया, कार्बन 11 हो गया. ये पीईटीज के अंदर ये ट्रेसेस इस्तेमाल किए जाते हैं. यानी कि दीज आर द एलिमेंट्स विच आर बीइंग taken inside the body, introduced inside the body with the help of any medication or with the help of any medicine, that they act as a PET tracer. They act as what? They act as PET tracers. So fluorine, oxygen, nitrogen, and carbon. So why is the beta positive emission is essential? और क्यों हमें पॉजिट्रॉन ही चाहिए बॉडी के अंदर? उसकी वजह यह है कि when tracer decays, जब पॉजिट्रॉन निकलेगा तो जैसे ही थोड़े से टाइम में ये पॉजिट्रॉन ट्रेवल करेगा तो बॉडी में जो इलेक्ट्रॉन्स प्रेजेंट होंगे, यानी कि उसका जो मैटर पार्टिकल है, इसका जो मैटर काउंटर पार्ट है, so when the positron and electron are going to meet, they are they are going to have a process, or they will undergo a process called as annihilation. They'll undergo the process called as annihilation. What is annihilation? तो याद रखिएगा annihilation कब होती है? जब भी एक पॉजिट्रॉन और इलेक्ट्रॉन आपस में मीट करें एक पॉइंट पे, तो एनिहिलेशन का प्रोसेस टेक प्लेस करता है. नाउ व्हाट इज एनिहिलेशन? एनिहिलेशन एक ऐसा पार्टिकल इंटरेक्शन प्रोसेस है, यानी कि मल्टीपल पार्टिकल्स का इंटरेक्ट करने का एक ऐसा प्रोसेस है जिसके अंदर पार्टिकल मीट करते हैं अपने एंटी पार्टिकल के साथ, और उनका जो सारा का सारा मास है वो कन्वर्ट हो जाता है एनर्जी इनटू दी एनर्जी. और वो एनर्जी रिलीज करते हैं किस फॉर्म के अंदर? इन द फॉर्म ऑफ फोटॉन्स. और ये हमेशा जो प्रोसेस है वो obey करता है लॉ ऑफ मास एनर्जी कंजर्वेशन एंड मोमेंटम कंजर्वेशन. तो बेसिकली व्हाट इज एनिहिलेशन? व्हेन one of the matter meet with its antimatter. जब भी कोई एक मैटर अपने एंटी मैटर के साथ टकराएगा, मीट करेगा, कोलाइड करेगा, तो what will happen? Its mass of both, not only the mass of one, mass of both will be converted into energy, energy of a photon. और वो एनर्जी हम किस तरह फाइंड करेंगे फिर? दैट एनर्जी इज फाउंड फ्रॉम अ फॉर्मूला E is equals to mc square, or we can also find the formula with the help of E is equals to hf, that how much energy is being produced uh, when the photons are being emitted. Yes, are you understanding what is the process of annihilation? Yeah, what annihilation means?
Yes.
Okay. So what actually annihilation, such type of annihilation is going to do when a positron and electron are going to meet. So when positron and electron are going to meet, so what is going to have? The two gamma photons will be produced. What is going to be produced? Two gamma photons are, yani two gamma particles are in fact produced. And what are gamma particles? We are pretty aware that these are the electromagnetic radiations formed of photons, and they are having small wavelength but high frequency. अच्छा, होता क्या है कि annihilation के process में two gamma photons are being produced, and those two gamma photons, the two gamma protons, both are having an energy equivalent to 511 kilo electron volt. They travel exactly in the opposite direction. They travel in what direction? They travel in the opposite direction to one another at 180-degree apart. And these photon pairs are detected by the PET scanner, which helps us to locate the respective problematic place very precisely. So these photon pairs are detected by the PET scanner, and they are allowing precise location of the tracer. So are you understanding what annihilation is and how it is working out in the case of PET scanner? So that is why it is being called as PET, positron emission टोमोग्राफी. लाइक सबसे पहले होता क्या है कि ट्रेसर बॉडी में इंट्रोड्यूस किया जाता है, उससे पॉजिट्रॉन एमिट होता है उस रेडियो एक्टिव न्यूक्लियाई से. जब पॉजिट्रॉन एमिट होता है, जैसे ही वो थोड़ा सा ट्रेवल करता है इनसाइड अ बॉडी, दैट पॉजिट्रॉन एनिहिलेट विद द इलेक्ट्रॉन. Annihilation means when two matter and antimatter, yeah, two particles and antiparticle meet at one point, so their mass is converted into energy. And here the energy is being produced in the form of gamma particles. So gamma particles, two of the gamma particles will be produced. And when two of the gamma particles are going to be produced, both the gamma particles will be moving in the opposite direction, right? Both gamma particles will be moving in what direction? Opposite direction. और वो दोनों gamma particles, ये जो आपका गोल सा रिंग है जिसमें बॉडी इंट्रोड्यूस की जाती है, उसमें डिटेक्टर्स लगे हुए होते हैं. So when the gamma particles are being emitted, they will be detected by the ring. They will be detected by what? They will be detected by that PET scanner. और उससे हमें पता चल जाता है कि at what specific location the tumor or the cancer is present in a body. So what are the applications of the PET? It can be there for cancer detection, for witnessing the brain activity, how the heart is functioning. It is also being done or is going to carried out for detecting the metabolic abnormalities and all. Yes, is this fine in understanding what is there in it?
Yes.
Okay, moving onwards, what next is there in it? So this is a PET scanner is. So inside a PET machine, there is one round ring So in this ring is actually acting as a gamma ray. Yeah, inside this ring there is a gamma ray detector, and the specific body part is being present inside this detector. So body is present inside a detector. So what happens? A body swallows the tracer. Tracer is going to be introduced inside a body, and when tracer is introduced inside a body, so it will be producing the positron. And when that positron is annihilated with an electron, it will give out the gamma particle. So let's say one of the gamma particle will be moving this direction, another one will be moving in this direction. Okay, it is going to, both the gamma particles are going to move in the opposite direction, and when they will move in opposite direction, so this is the instant which will help us to diagnose where the actually cancer or tumor is present inside the body. So this annihilation process is being shown inside here. Okay, actually this is a tracer, and what is happening here? So positron is moving, it will hit the electron. When it hits the electron, so one of the gamma ray will be moving to the right, another gamma ray will be moving to the left at 180 degree to the first one. So this is an annihilation process. So the PT scanner is a ring of gamma detectors surrounding the patient. Both photons arrive at the opposite side of the ring at same instant. तो एक ही instant के ऊपर दोनों जो हैं gamma rays they are going to arrive, and this coincident detection, अच्छा इस तरह की detection को जो gamma rays आपके detect हो रहे होते हैं ना, इसको इस तरह की detection को it is being called as coincidence coincidence detection. This coincidence detection identifies the line along which annihilation occurred. ठीक है, दिस कोइंसिडेंस डिटेक्शन हमें क्या बताती है कि कहाँ पर आपकी एनिहिलेशन का प्रोसेस अकर किया, और ये सारा प्रोसेस रिपीट होता है फॉर मिलियंस ऑफ टाइम्स, और उससे एक 3D इमेज आपके ट्रेसर का या ट्रेसर की डिस्ट्रीब्यूशन का फॉर्म कर लिया जाता है मशीन से। और वो जो 3D इमेज होता है, इट हेल्प्स अस टू सी हाउ दैट रिस्पेक्टिव बॉडी पार्ट इज working or functioning accordingly. Is this fine?
Yes.
Okay. So last but not the least, so this is one of the small exam question related to the PET scanning. तो वो तो बेसिक तो ये पूछा जाता है कि PET स्कैनर क्या है, PET में ट्रेसर कौन से यूज होते हैं, ये किस तरह के यूज होते हैं, एनिलेशन से क्या मतलब है, वो सब तो हमने डिस्कस कर लिया। PET का मैकेनिज्म क्या है वो भी हमने देख लिया। बट आपको कुछ मैथमेटिकल क्वेश्चंस भी PET स्कैनिंग में पूछे जा सकते हैं। सो व्हाट कैन बी आस्क्ड फ्रॉम यू इन द केस ऑफ PET scanning? A question can be asked कि calculate the total energy released in one annihilation. So एक annihilation में total energy कितनी produce हुई है वो आपको आना चाहिए, how it can be found. So I taught you earlier that energy can be formed from a formula E is equals to mc square, and we know that in the process of annihilation there is one positron which is connecting with one electron. Both of them are meeting at one point. So in the formula E is equals to mc square, we are going to take the mass of both, we are going to take the mass of both positron and electron. So what is the mass of positron और इलेक्ट्रॉन? इट इज 9.11 टू 10 पावर माइनस 31. सो उस मास, क्योंकि दोनों का मास लेना है तो उसको वी आर गोइंग टू मल्टीप्लाई इट विद 2. So this will be the energy, and we know c is the speed of light in vacuum, 3 into 10 power 8 whole of square, and the energy we are going to get is what? It will be 1.64 into 10 power minus 13 joules. So this is actually the amount of energy being given out in a process of annihilation. Yes, are you understanding? In the process of annihilation,
Yes.
how we have to find out the total energy. This is the way out of finding the total energy is equals to mc square. And last but not the least, it can be asked to find out the wavelength of each gamma photon. तो हर gamma photon की अपने wavelength find करनी है. So we studied this in the chapter of quantum physics, how we can find out the wavelength with respect to the energy. So we know we are having one formula, E is equals to h of f, and if we just write instead of frequency, we can write this formula, V is equals to f lambda. So it can be written as C divided by lambda. So hc divided by lambda, in this, using this formula, E is equals to hc divided by lambda, we can find out what? The wave length. We can find out the wavelength. So E is equals to hc over lambda will help us to find out the wavelength. So what is E? E is this energy, 1.64 into 10 power minus 13. But we have to find out for single photon, each photon, we are going to divide this energy by 2, because this energy was for two specific particles, right? Then h is the Planck's constant, which is 6.63 into 10 power minus 34. C is speed of light, 3 into 10 power 8, and lambda is unknown. So we'll make lambda as a subject, and we are going to get the value as lambda equals 2.4 into 10 power minus 12 meter. So this is going to be the wavelength of each gamma photon. Yes, is this understandable?
Yes.
Okay, so this is it in the PET scanning, and here we are going to stop our class.